Hello, Aart-Jan. How are you?
Hello, good afternoon. I'm
Good
fine.
afternoon. Thank you for joining us. And Aart-Jan's going to give us a presentation on inkjet printing for applications with small size features. So as always, I'll hand over the stage to him, and then I'll come back at the end to take your questions. Over to you. Good luck.
Thank you. Thanks for your introduction. Thanks for joining the presentation. As mentioned, I would like to take you on the journey towards smaller feature sizes and the role which we foresee for inkjet printing on this journey. Let me give a bit of introduction, starting with the company which I'm representing. Our company, Domicro, is a high-tech SME from the Eindhoven area, which is very much rooted in the inkjet printing experience and technology. What we typically do is we provide engineering services to customers in early stages of product development. Think about making a demonstrator of something very innovative with printed electronics, or about, for example, contract research and development. We do that for a lot of application areas like automotive, where, for example, in mold is a big theme at the moment. We have recent experience in healthcare with microfluidics devices where small interconnections were needed. An important one always is wearables, wearable IoT devices, which you can take with you, which report about lots of parameters to be measured. And certainly semicon is a big one as well. With, for example, the assembly of chips with very fine pitches. Having said that we are an engineering company with lots of services in the product development range, it's important to notice that, that we also have a laboratory available which can support us with making various demonstrators and prototypes. We, of course, have a laboratory with inkjet printers because that's the core of the company, the background in inkjet printing. We have two LP50 printers from the company SÜSS Microtech, which you can show on the left hand of this picture over here. We have analysis equipment in the clean room. On the right of the picture here is a microscope, a Keyence optical microscope, which can be used for inspection of the products we have made. And also important is that we have a lab for system integration and for electronical testing outside the clean room. Not shown on the pictures, but also very important, is that there are facilities for curing the samples that are made. We can do thermal curing, we have laser curing equipment, we have a fine placer for putting the components in a very precise way on the substrate, and in that way we can make prototypes a reality. Talking about small feature sizes, where are these important? Simply speaking, the answer is almost everywhere. Obvious examples, which are highlighted here on the left-hand side, are the semicon industry, with the chips getting more complex by the day almost, and where the pitches can be very small and put a lot of challenges on the integration in the circuitry. Automotive is a big one, thinking, for example, about in-mold applications, smart glass applications, where small features are needed, for example, for making bendable substrates, bendable products that can be integrated in a curved surface. The solar industry, where parameters like transparency and invisibility of the interconnections are dominating, is a big one. Wireless IoT, wearable devices do play a role, and certainly also the healthcare industry, in particular the microfluidics area, where small connections are to be made. What is the need which is coming from these applications? To put it simply, it's a lot about adding as much as possible functionality in as small a space as possible. The typical targets we are talking about in the context of this presentation are that we should offer heights on flexible substrates up to about 100 microns at most. At the same time, we also need to offer fine pitches, for example, because of the very complex chips we are talking about, with pitches, let's say, in the area down to about 100 microns. In the picture below, we see an example of a controller chip which is integrated on a flexible substrate all the way with inkjet printing. Later, of course, more backgrounds about how exactly that has been done. Talking about small feature sizes and the role of inkjet printing, the thought is, why would you want to go to printed interconnections? There are a couple of important reasons to consider this.